welcome to Pandio. I'd like to welcome today Charles Givre. Charles is a solutions-focused senior technical executive and data scientist. So we're super excited to have Charles with us today. Charles, welcome. You can just kind of give a little introduction on yourself, a little background.
Yeah, thank you very much for having me. My name is Charles Givre. I'm a founder of a new startup called Data Distillr, where our goal is to make data much more accessible. Prior to that, I worked at as a data scientist in a managerial capacity at two major banks, Deutsche Bank and JP Morgan Chase. And before that, I have about 12 years of experience in the intelligence community doing various analytic and data science work.
Fantastic. So rich background kind of across multiple industries, and certainly you've been kind of in data science here from quite a while. So I'm interested, Charles, just in the last kind of 10 years, can you talk a little bit about how data science has evolved and kind of what you've seen as kind of the major trends?
First off, I think we've seen data science and data analytics being applied to a much wider swath of industries, which I think is generally a good thing. When I first kind of started going to conferences, pretty much what you would hear is like there would be a million presentations on how to analyze Twitter feeds. And that was kind of the bulk of it. And then, several years later, you would start to hear a lot more things about how to analyze restaurant data, how to optimize, manufacturing processes or IoT, stuff from IoT devices. So it got the types of problems that were being tackled really started to expand, which I think is a great thing. I think you've seen a lot of development over the last few years in terms of tool development and kind of removing data science from this niche of an elite skill that only the few possess to a skill that is becoming much more commonplace, that these kinds of things are going to be practiced by much more people in the foreseeable future. So I think that's a growing trend, and that's due to first off just understanding of what's possible, but also I think the tools are getting easier and easier to use and more automated, and that's generally a good thing. And so hence more and more people are capable of applying these technologies to a wide variety of problems.
And talk a little about kind of the day-to-day for a data scientist as it was, when you started and what it is today. So you talk about kind of all these tools that have come out. So what does that
Sure.
mean for kind of the actual day-to-day work?
So when I first started doing this work, I'll tell you my story was I joined Booz Allen almost 10 years ago, and I started working on a project, and this was probably my first data science project, though we weren't really calling it that at the time. And basically the reaction at the time was, so I was part of a 600 plus person analytics group that was in a major government agency, and the contract that we had with the government was to provide analytics. So I built this analytic tool that automated all these things that we were doing, derived all these new insights from our data, kind of standard data science project. And I showed it to the government overseers, and their reaction wasn't really so much, wow, that's amazing. It was more like, why are you writing code? We hire you to analyze data. And so I think that mentality is no longer there. People understand that there's a distinction between writing code to build systems and writing code to do analysis. So people have kind of there's a greater understanding of that. I guess where I was going with this also was that there is a greater understanding of being able to extract a lot more. Like when I started, people didn't really have this idea that you can do all these different things with data. It was kind of just like search for stuff, find it, present it. And now there's a much greater understanding of you can predict things with this. You can make recommendations. You can then automate this whole chain from end to end, and so that you can kind of take humans out of these decision processes and ultimately the goal there is to actually make it so that people can focus their time on things that really do require human attention versus things that don't. So that's kind of, I think, the big change.
Okay. So when you talk about kind of taking the humans out, which I think is kind of segues nicely into kind of the whole machine learning kind of paradigm. So, one of the things we talk about at Pandio is, there used to be, we went through this phase of kind of big data analytics, but now, the world is shifting towards really implementing and automating through machine learning and removing, if you will, a lot of humans from processes that like you talked about, they don't really need to be involved in. So, what are the implications of that? Kind of what do you see as how that's going to change both kind of society and also kind of as a data scientist practicing, what does that actually mean for kind of your role?
While these automated tools can build a model that is very accurate or performs very well, you still require the human thought to actually apply that to a business problem. That's not going to go away. I don't think in the foreseeable future computers will be smart enough to actually figure out business problems like that. And so that's something that is very important. And then the other part that is not going away is the actual data engineering to go from raw data sources to something that you can actually feed some of these automated machine learning tools. So, and that's always, in my view, the kind of the elephant in the room. It's like, if you have easy data, then it's not a problem. But in so many industries, you don't have easy data. If you look at like bioinformatics or security or finance, a lot of times data is in very difficult formats. It's in very difficult systems, or it's just spread all over the place. And you have a lot of work to do to even get it to the point where you can actually start your analysis. And so in my view, and this is what the company I've started is actually focusing on, is making that process a lot easier, automating what we can, but just generally making that working with data step a lot easier. And so I guess by default there, my money is on that's going to be a need in in the future.
Charles, can you give a use case? You talked about financial services, where I know you spend a lot of time. Um, Talk about kind of the types of different data sources that are difficult to access and why there's so much
Sure.
complexity at that point.
Sure. So a lot of it will depend on the company you're working for and or the company, how old it is, what their infrastructure looks like. But one of the projects that immediately comes to mind that I worked on was a project to detect money laundering and to build some models around that. And we were working with data that was in a format called Swift messages. And um, the when I started working on this project, the goal was, since Splunk was the main analytic tool that the company used, the goal was to simply put these Swift messages into Splunk, which from a data scientist perspective, Splunk produces a mess, and then the Swift messages are a mess. So you have like mess squared. And frankly, the Swift messages are probably one of the most difficult formats I've ever seen in terms of being able to analyze it and just get it to a clean state. So that was one major challenge that we've had to work. But to kind of take it up a level, an industry like that, because there's so much riding on their systems, and and there's in terms of security, policy, laws, and so forth, they can't just like dump the data into cloud and call it a day. That's just not going to happen. I mean, there were systems I had heard about. I'd never actually seen these, but at Deutsche Bank that had been running for 30 years and nobody would touch them because so much money was being processed by them. And if they went down for any reason, it would be like, absolute calamity. So they just like don't touch it, leave it alone. So you'll find situations like that where you have these legacy systems that are crucial for business operations that produce valuable data in some format that we wouldn't pick today. And I think that situation is a lot more common than people may realize. I remember I worked with a radio station that it was a classical radio station, so they do all their programming because it's longer pieces of music, so they plan it out a lot farther in advance than you might think. They use this rather archaic database to do their programming, and the end result was that if we wanted to do any work with this data, you had to figure out a way of getting it and mapping it to a more modern data structure. I think that those situations are a lot more common than people realize. In the months since I've started my company, I've realized that there is somewhat of a disconnect between Silicon Valley and kind of rest of the world, where like the Silicon Valley and perhaps Seattle just kind of don't grasp that is the reality in a lot of other companies, where they just have data that's in these old systems, and it's extremely complicated and or costly to move the data into more modern systems, and so it might not be cost effective for them to do so.
So from your perspective, with your new startup, what is kind of the value that, what's the value prop that you're giving to these clients then?
What our tool does is it connects to a wide variety of data sources and lets you query them in place, regardless of the format or underlying structure. And we use SQL as our query language. So if you know SQL, basically it means that you can now query all sorts of data that would otherwise be inaccessible. So like blockchains, APIs, databases, Elasticsearch, Splunk, all this stuff, you can just type a SQL query and you're off to the races.
Okay. Okay. Um, that's super interesting. One thing that you talked about there was kind of Silicon Valley maybe is a little bit out of touch, and I'm wondering there, when we look at some of these fintechs as an example, or the insurtechs that are kind of turning these, that are coming in and kind of taking market share from these kind of legacy players, and part of that seems to be because they don't have all this legacy kind of infrastructure that they need to work through, right? How do you see that kind of playing out as kind of because these monolithic kind of these very large banks, they have, like you said, decades and decades of data and infrastructure, and so how do they make that transformation to compete with these new players that are coming onto the scene?
Yeah, it's a tough one. It's kind of like, I mean, I think it's really, I should be clear that I'm not arguing that the banks should like their approach, it is what it is, but that should not be the ideal approach. I mean, the ideal approach should be to use the modern techniques that are as possible. What I remember seeing, and what was very frustrating, I saw this from like the large enterprise perspective, and now I'm seeing it from the startup perspective. But what was always very frustrating for me when I was working for the large enterprises was you would see these startups that have amazing technology, and you'd want to bring them in, and then you'd start talking to them, and you'd say, okay, we have the following security requirements that we really can't compromise on,
Mhm.
like a single sign-in, like I don't know, for if you're talking about banking data, there's all kinds of laws that we have to comply with, and if you don't, there's like massive fines that you don't want to mess around with that. And then security and all these other requirements. And I get that for a startup it's very difficult to comply with these things, especially in the beginning. But it was always very frustrating that you would see all this amazing technology, it's out there, and you just can't use it because it's not enterprise grade. And so yeah, that's I don't know how we get around that, but I think ultimately enterprises are going to have to figure out how to work with small companies, how to get these tools, and just to make themselves competitive, because it's I mean I think it's not going to be acceptable. I mean, a great example I think is healthcare. Like, why are they still using faxes to communicate? And
Mhm.
part of that is due to regulations, but which is another topic. But it you would think that in this day and age we could figure out how to send communications securely. We have, rather than the fax machine, but it still exists, and until we figure that out, I mean, I think
Sure,
yeah,
sure, sure.
it's out there.
So
I
I'd
hope
like
that answers your question.
No, no, no. I think that does help. I'd like to dig a little deeper on this whole kind of stepping back to the machine learning piece. So it seems like one of the things you mentioned was, access to enough data, right? So to actually make the machine learning models valid and like you said, garbage in, garbage out. You need enough data. It's got to be clean data. And it seems like, the larger players, who have had kind of have the money and the resources have figured this out, right? So
Hmm.
the Googles, the Facebooks, the Amazons, the Netflixes of the world. My question for you is, what about the average large enterprise, right? That
Hmm.
doesn't have maybe billions of dollars to invest in infrastructure and make sure they have the right they have the right data. What do they do, like in the next 3 to 5 years? How do they make sure that they don't get kind of left behind as
Right.
more of the world shifts in this direction?
I think what they need to do is, and this comes down to having good leadership at the top levels, who understand both understand how to build data science teams, how to build data science infrastructure, and how to really use this to solve business problems. But I think what it comes down to is for them to find problems where they can add value quickly. And then once you've done that, then plant that flag and then expand from there. And I know in our case, I saw this at JP Morgan. The first use case that the security data science team tackled was fraud, was
Yep.
detecting fraud. And that's a great one because it's very easy to say, look, our model detected X million dollars of fraud. We want half of that for our annual budget, and we can do 20% more, or 50% more, 2x more than that. So it finding problems that will add business value and are, let's just say, relatively easy to solve with what's available. I think that's probably the first approach that I would take if I was like leading a corporate, a corporation from nothing, with respect to data and data problems. So I think so. It's incumbent on the leadership to kind of demand that of the data teams, but I think it's also incumbent on the data scientists to understand that their work is not a research project. They're there to deliver business value, and so whatever they're working on, they need to make sure that it ties back to the business, and also is actually adding value. And being able to articulate that value clearly to the stakeholders, I think, is really important. So in other words, data science isn't just an academics exercise, it's solving a business problem, and being able to articulate that is I think what will help companies kind of grow in the right direction. Because I've heard so many stories of companies making massive investments in data infrastructure and data science, and then 6 months later they're really disappointed with the results because they just haven't produced anything. And I think perhaps in many cases it's not fair to say they didn't produce anything, but just the value proposition was not understood.
Mhm.
And so and that can be in many ways. I mean, it can be in terms of actually generating more revenue, it can be in saving money, it can be in saving time. There are a lot of things that can be done with data science that, I mean, that will create value. So it's ultimately, it's up to the executives to understand that value, but it's also up to the data scientists to actually be able to articulate that value and make sure their work maps to generating value.
I think that's great advice. So for you, it's about kind of identifying upfront areas where the data science team can drive business value immediately,
Mm-hmm.
and make sure there's an ongoing dialogue between the two sides, right? The business and the data science. And if you get that right, if I hear you correctly, then you get more opportunities to
Yes, absolutely. And I mean, I know of I know of a story. A former colleague of mine, and she was working at a gaming company, and I mean, she did this really awesome project, and they went to present it to the C-suite, and uh, I don't want to say too many details and embarrass the person, but I mean, she talks about it herself, so it's not like a secret. But basically, her project kind of rediscovered something that was already known, and like making sure you're not doing things like that is just really really important. Ultimately, just being able to clearly articulate the value of what it is you're delivering. I think that's a really vital data science skill. I mean, and I think something like that needs to be taught when in data science programs, just remembering to teach people like, this is a business problem you're trying to solve. If your model is 91 or 92% accurate, great. But what difference does that make to the people that are writing the checks? That's what really ultimately comes down to in the business world. So that's kind of
well,
my thought on the matter.
yeah, no, I think that's interesting, and it makes it sound like, as a data scientist, if you were giving career advice, it sounds like the data scientist not only has to be kind of good at the craft, but they have to have the ability to talk across the business.
I think it's very important. When I was at when I was at Booz Allen, we had kind of two types of data scientists. We had, I would say, more of the like academic types, and then we had more of the people that kind of grew up with the skills more organically, I guess. And the second category of people were much better at kind of delivering solutions that the clients actually wanted, and the more academic types kind of really struggled because they weren't handled this clearly defined problem, which I found very interesting. Because academic research, you're not given a clearly defined problem. You kind of have to come up with something original. And ultimately write a dissertation or something like that. But it was very interesting to me to see how a lot of them really struggled with kind of that idea of value creation. So I think it's really important that that people have that in mind when they do data science. Now, does every data science just need that? I'm not sure, but I think if you're considered, most companies have data science teams. Somewhere along the line, somebody in the team needs to speak for the team, and needs to be able to articulate what they're doing clearly to non-technical stakeholders, and and understand and be able to articulate how that fits in the greater business context.
Okay. And I'm just curious too, on the engineering side of the house. So from the data scientist, if you're giving again, career advice to a data scientist, how do you see the roles evolving in terms of data engineers, DevOps, ML ops, and kind of where do the data scientists fit into that spectrum? I guess.
Yeah, that's a good question. And I think some of these job titles are really very much evolving. When I started, it was kind of expected that data scientists would know everything about everything in those areas, which is it's not really a realistic expectation, just because you can't have expert level expertise in all of them. It's just it's almost impossible to find people like that.
Yep.
Um, and I mean, I know from my own experience, I mean, there are things that I have much more expertise in, and so I mean, I know where I fit on that, but I think there probably will be more specialization. You probably are going to see that, but I do think it is a good idea for data scientists to at least be conversant in a lot of these areas, and I think not understand, like, I've worked with data scientists who perhaps don't understand the data engineering aspects as well as they should, and I I see that as a little problematic, because then they're not understanding like why their code is not running efficiently, or why things are taking so long, and it's like, well, you have to understand how that underlying source system is working, so that you can take good advantage of. One kind of silly example that I've seen like this is, I've seen people, someone I mentored, they were working with a relational database, and what they were basically doing was writing Python code to dump the entire database table into memory, and then working on it from there. And so the first thing I suggested to this person was like that she should learn some SQL commands and do all that processing in the database, because that would be much more efficient than writing the Python code to do
Mhm.
that. And you also get a repeatable process, more so than Python, and so forth. So like those kinds of things, I think are very important for data scientists in the future. So as the DevOps and data ops and all these kinds of things grow, data scientists should make an effort to be conversant in these, and not just view them as, oh, that's somebody else's job, I don't care about it.
Okay. Well, I think this has been a fantastic kind of state of the union from you on kind of data science. Charles, if folks want to get a hold of you, do you want to kind of let them know best way to kind of hear about, kind of your new company and reach out to you?
Sure. So my email is charles@datadistiller.com. Please feel free to connect with me on LinkedIn, and yeah, I'm happy to talk to anybody about this kind of stuff.